Maple TA Lesson 11B, homework question number 6. Solve the following independent system of equations. Remember, independent means that these will intersect and have a solution. Dependent meaning that I end up having two lines right on top of each other and they intersect with infinite number of intersections. And inconsistent meaning that I have two parallel lines that will never intersect. And so there won't ever be a solution. Okay, so it was nice of them to tell me that it's independent, so I will have a solution here. And I have a couple of different methods I can graph these, but in this case, it's asking for an algebraic one because there's no graphing system down here. So the first thing I'm going to do is take one of these and solve for any variable. I'm going to go ahead and do this one, I guess, just because. So I'm going to solve this for x. Sure. It doesn't matter. So the first thing I'm going to do is get rid of the y. So I'm going to add 5y to both sides to keep it balanced. And so negative 5y plus 5y is 0, and I'm left with 2x on the left side of the equation. And I'm trying to get my equal signs lined up. There we go, so that it looks nice and symmetric. So then I have 5y and negative 30, and just to stay consistent, I'm going to put the 5y first and the negative 30 at the end. To continue solving for x, I need to divide both sides by, or every single term is another way to think of it, by 2. That keeps this consistent. Oops. Divide this by 2. Divide this by 2. And then I have my, then I'm going to take this one right here and just copy and paste it down here just because. 2 divided by 2 is 1. 1 times x is x. 5y divided by 2, I'm just going to keep it as 5 halves y. And 30 divided by 2 is 15. So now that I have this solved for x, I can take this right here and the other equation, not the same one. If I do the same one, I'll end up with something like negative 30 equals negative 30, and that doesn't help us. So I need to make sure that I use the second equation and substitute every time I see the x in here with everything that the x equals. So I'm going to put that in where the x was. Okay, so now I need to do the distributive property. 3 times 5 halves and 3 times 15. 3 times 5 halves gives me 15 halves, y. 3 times 15 gives me negative 45, and minus 4y. Equals negative 17. Haven't done anything over there yet. Okay, so now I have 15 halves y and negative 4y. Now I need to get a common denominator so that I can combine these y's. 4, I can put it over a 1, and then to get the common denominator of 2, multiply that, the top and bottom, by 2, put that over a 1, so that 2 times 4 is 8, and 2 times 1 is 2, so then I have 15 halves and 8 halves. So I'm going to come down here on the next step just to show that right there, that I'm going to be multiplying the top and bottom over here by 2, which makes it 8 halves. Now the reason I can do that is 8 divided by 2 is 4, so I haven't changed this value at all. I've just rewritten it as a different kind of value, 8 halves. 15 halves minus 8 halves, 15 minus 8 is 7, 7 halves, so I end up with 7 halves y. 7 halves y minus 45, and that's still equal to our negative 17. Okay, so now I need to continue solving for y, so I'm going to add 45 to both sides, keeping that balanced, that equal sign balanced. Some of you may have heard that, instead of writing it both times, at this point some of you might be comfortable just saying it's negative 45, and so when I cross it over the equal sign, the shortcut way is thinking of crossing it over the equal sign, it changes the value. So some of you might want to are already doing that, and you can continue doing that. I'm going to do it this way to show so I don't lose anyone who might be confused at the shortcut. Okay, so negative 45 plus 45 is canceled out to 0, so I'm left with 7 halves y, and then I have 45 minus 17, which gives me, just going to grab my calculator instead of pulling up Excel. 45 minus 17 really fast is 28. There we go. I know, I could have done that in my head. Some of you already did. Let's see. Okay, so now the next thing I need to do is 7 halves times y. So to get rid of the 7 halves on the left-hand side, because it's a fraction times y, I need to divide by that fraction, or I can think of multiplying by the reciprocal because it's a fraction. And so I'm going to go ahead and do the reciprocal. So it ends up being multiplying it by 2/7. And you'll notice on the left-hand side, 7 times 2 is 14, and 2 times 7 is 14. 14 divided by 14 is 1. And that's how I can get rid of it. Dividing by or the fraction, or multiplying by the reciprocal. So I'm going to write it by the reciprocal on this side. That's how we divide fractions. So I end up with 1y, or just y, and 28. 28 times, or let's do 28. Let's divide it by 7 first, because we could multiply. Let's multiply it by 2, and then we'll show that you can do it either way. Okay, so 28 times 2 gives you 56 divided by 7. 56 divided by 7 is 8. Or we can do 28 divided by 7, just so that you are simplifying the top and the bottom. So 28 divided by 7 gives me 4, and then I'm left with this 2 on the numerator, so 4 times 2 is 8. Either direction, it's up to you. Okay, so I end up with y equals 8, and I'm going to make that big and bold so I can see that that's the answer. And then to find x, I'm going to go back to the equation here that I solved for x. I could choose either of these. It doesn't matter, but this saves me a little bit of time because I've already solved for x. So I'm going to throw in my parentheses, and then 8 is the only thing that needs to go inside there. Again, I can divide this first, 8, because the 2's on the denominator. 8 divided by 2 is 4. 4 times 5 is 20. If you're not comfortable with that, you can multiply these first. 8 times 5 is 40. 40 divided by 2 is 20. Either way, we get 20. So equals 20 minus 15. 20 minus 15 gives me 5. So I have the solution 5, 8. All right, and we can put that in here. 5 and 8, and to verify we can check how did I do. Those of you who would like to see the elimination method, I'm going to do it over here. It's a little bit more difficult considering I have not as nice of numbers, but it will still work as well, just for those of you who want to go through it. Those of you who don't, go ahead and stop the video now because it might have a lot of fractions that might throw you off. Okay. Only on the elimination method do you need to memorize if I have x equals a number, that means I end up with a solution. If in adding these, the system of equations, if I end up with a true statement, such as 30 equals 30, then I know that I have two lines that are dependent and they'll intersect at any point. And if I end up with a solution that's not true, a false solution like 0 equals 3/5, then I know that I have an inconsistent system. I don't believe that you're going to be asked to find that, but I'm not going to guarantee that. So just keep that in mind as we do the elimination method. Here I notice that there isn't anything nice to eliminate the x or the y like on the previous example. So in this case I'm going to multiply both equations by something so that I can cancel something out. So here I can multiply this by 2 and this by 3 so that they end up being 6, or 5 and 4 so that they both end up being 20. Either direction. I'm going to leave these here, but my working ones I'm going to come down here. And since x is first, we're just going to keep it like that and get rid of x, just because. So the top one I need to multiply by 2, and the bottom one I need to multiply the entire thing by 3. And I need to decide which one I want to be negative, because I want to add these, and then it will cancel out, in this case, the x variable. So it doesn't really matter, so I'm just going to do it here. We'll do negative. And then I'm going to give us our bar right here so that I can see that I'm adding these two together. Okay, and then my answer does not need to be underlined. Okay, so 2 times 3, I guess we should do that down here so I can show the next step. If you were doing this by hand, it would probably look a little nicer. 2 times 3 gives me 6. So this is 6x. And again, the distributive 2 times negative 4 is 8. And 2 times negative 17 gives me negative 34. On the bottom I have negative 3 times 2x, and that will give me, I guess I'm just going to have to delete it, negative 6. And then negative 3 times negative 5 gives me positive 15. Oops, positive 15. And then negative 3 times negative 30 makes it positive 90. Okay, just double check my work here. 2 times 3 is 6, 8, 34, 6, 15, 90. Okay, so the positive 6 plus negative 6 is gone. Negative 8 plus positive 15 gives me negative 7. And I don't want that underlined because we're at the answer now. Positive 7, did I say negative? I meant positive 7y. And then I have negative 34 and positive 90, so that gives me a positive 56, is that right? Yep, so positive 56. And then I need to continue solving for y. To do that, I divide both sides by 7. And then y equals 56 divided by 7 is 8. And that seems to match what we did before. So now I'm going to take this and put it into either of the equations. It doesn't matter. We'll pick the bottom one just because. So we'll put it here, and then where this y is, I'm going to put in 8, and then I have 2x, negative 5 or minus 5, or negative 5 times 8 gives us minus 40, equals negative 30, and then continue solving for that. I need to add 40 to both sides, or you can just say, since it's crossing the equal sign, it becomes positive, so we're going to just add 40 over. Then I have left on the left-hand side 2x, positive 40, and negative 30 is positive 10. And then divide both sides by 2. 2 divided by 2 is 1, which leaves me with x. 10 divided by 2 gives me 5, and the answer, 5 and 8. So that was the elimination method for those of you who continued to stick around.